Assalamualaikum warahmatullahi wabarakatuh and good day to all my students. Welcome back to my lecture. Today we're going to continue to new chapter, which is Analysis of Cable for chapter 4. And the course outcome for this one, we are able to analyze the arch and cable to determine the direction and internal forces in arch and cable. So for cable, we're going to study cable subjected to point load, then subjected to UDL, and also the combination between point load and UDL. For today, we're going to do example on cable subjected to a point load. In this analysis, cable are considered perfectly flexible. Therefore, bending of the cable at any section must be zero, and the cable can only transmit load to the support by the means of tension acting along its length. Now, let's do for case 1. For this one, we need to determine the tension in each segment of the cable. So, supported at A and B. So, draw the free body diagram. Due to the support at A and B, we're going to have reaction on horizontal and vertical. So, we assume that is the direction for forces at the support. So we take the entire structure, summation moment at A equal to 0 and positive to the clockwise. Then check for each forces. So take for VB going up to point A is anti-clockwise, therefore is negative, and distance for that one is 10 plus 20 plus 20 and plus 10, so 60. Then take another force, which is we take this 10 kilonewton to point A is clockwise, so positive, and distance for that one is 10 meter, so 10 times 10. And then take for another 10 kilonewton, distance for that one is 20 plus 10, so 30 meter. Then plus the last one to point A is clockwise, so positive 15. Distance for that one is 20 plus 20 plus 10, so 50. So from that we can get our value for VB is 19.17 kilonewton. Then take summation of Fy equal to 0, positive upward. So we don't know yet what is our VA. So VA going up, VB also going up, so plus VB minus 10. So this is 10 minus going down, minus 10, then minus 15 and equal to 0. Then we get our VA is 15.83 kilonewton. Then we need to calculate the horizontal forces. So we take segment EB. We know this forces 19.17 kilonewton. We don't know what is HB. So we take summation moment at E equal to 0, positive clockwise. HB to point E is clockwise, so positive HB, and distance for that one is 5 meter times by 5. Then 19.17 to point E is anti-clockwise, therefore negative 19.17. Distance for that one is 10 meter, so time by 10. So we can solve this one and we get our HP is 38.34 kilonewton. Then we take summation Fx equal to 0, positive to the right. Please remember, whole entire structure. On the other side, we have HA. So HB minus HA equal to 0. So we know what is our HB. So how we get our HA is 38.34. Therefore, HA is equal to HB on the support. Next, we need to calculate forces in each cables. First of all, we take segment AC. So this one for segment AC. And we don't know what is our YC. We know our HA 38.34 and our VA is 15.83. And at point C, we have 10 kilonewton downward force. So we take summation moment at C equal to 0, positive clockwise. So therefore, for 38.34 to point C is anti-clockwise. Therefore, 38.34. Distance for that one is YC, we don't know yet. Then 15.83 to point C is clockwise. So positive 15.83. Distance for that one is 10 meter. We have this equation, so we can solve and we get our YC is 4.13 meter. Then we need to calculate force TAC. Please remember, the forces in cable in tension. Therefore, this is the sign of tension in the cable. So we cut it half. So this how it look like. And here we don't know yet what's the angle here. So as you can see here, this force is going up, this going out here. That means forces in cable is this way. Then to do this, please remember the trigonometry, this formula, the CH4 formula to calculate this angle. We know these forces and these forces, so we can find what is our TAC. Also, please remember how to resolve our force at certain angle into this direction and into this direction respectively. Now, we need to calculate what is our angle theta. So, we take tangent theta equal to opposite. The opposite is 10 meter here. The adjacent on that one is YC. So 4.13. Then we get our theta is 67.56 degree. Then take summation of force in Y direction equal to 0, positive upward for this system. Then we know here is 15.83 going up, so minus, because this in that direction, that's mean going down, so we have to resolve that into Y direction. So we have TAC cos 67.56 degree equal to 0. We solve this and we get our TAC is 41.47 kilonewton. Now we're going to calculate force in segment CD. This is segment CD. We don't know yet what is our YD here. So we know these forces here and all the distances. So take summation moment at D equal to 0. Here is our D, positive clockwise. Therefore, for 10 kilonewton to point D is anti-clockwise, so negative. Distance for that one is 20 meter. Then for 15.83, that's going up to point D is clockwise. Distance for that one is 10 plus 20, so 30. And for 38.34, to point D is anti-clockwise. Therefore, negative 38.34. And perpendicular distance for that YD we don't know yet, so times by YD equal to 0. So we have one unknown, so we can solve that and we get our YD is 7.17 meter. So we know what is our YD is 7.17 meter. We know distance here, we get this distance here is 3.04 meter. Now we need to find force for TCD. This is tension in cable CD. we cut it half, so this is how it look like. So theta is here. To calculate theta, tangent theta is 3.04 divided by 20. So here 20. So we get our theta is 8.64 degree. Then we take summation Fy equal to 0 positive upward. We have in y direction 15.83 going up, so positive 15.83 minus 10 because it's going down. Then for TCD we have to resolve into y direction, so TC minus TCD sine 8.64 degree equal to 0. Then we get our TCD is 38.8 kilonewton. Next we go for segment BE. So this from the main free body diagram, we know this distance here is 10, here is 5, therefore we can calculate our theta. So theta here, so our theta is tangent theta 5 divided by 10, and we get our theta is 26.56 degree. Then we take summation Fy equal to 0 positive upward, therefore 19.17 upward positive. Then TBE we have to resolve into y direction, therefore TBE going down, negative TBE sine 26.56 degree equal to 0. We can solve it and we get our TBE is 42.87 kilonewton. Then we need to calculate for segment ED. So this how the whole system for EDs look like. So here is our ED segment. We know all the forces, so we can get this distance here is 2.17 meter. Then we are able to calculate our theta, and we get our theta is 6.2 degree. Then take summation of Fy equal to 0 positive upward, so 19.17 is going up, so positive minus 15. Then our TED is going down, so we have to resolve that into y direction, so TED sine 6.2 degree. So we can solve this one and we get our TED is 38.61 kilonewton. Then how about the length of cable? So we have to assume each segment to be straight and the safe weight of the cable is negligible, so we can find the length of cable. So this how whole segments look like. We know all the distances already, so we can use trigonometry. Please remember this formula. We know A, B and C, then we can get our C. So for this case, we have this triangle, we have this triangle, we have this triangle and this triangle. Therefore, we are able to calculate length of this cable. For first triangle, it's 10 power of 2 plus 4.13 power of 2 square root, plus second triangle 20 power of 2 plus 3.04 power of 2 square root, then plus the third triangle, so this one is 20 power of 2 plus 2.17 power of 2 square root, then plus the last one, the fourth triangle is 5 power of 2 plus 10 power of 2 square root. So we get our length for this cable is 62.34 meter. So what do we learn from this example? As what we find out, the maximum tension occur at maximum reaction point. Then the minimum tension occur at the lowest point of the cable system.